thought we'd talk about the interconnection for a grid-tied solar electric system, a PV system. We're here at the Riverwalk building in downtown Davis. This building has a 2.4 kilowatt PV array on it. It's noontime, it's a beautiful sunny day, and the PV is ripping down some watts right now. If you look at the electric meter here, this is an old mechanical meter that I've installed, and it shows you by spinning here rapidly that we're making a lot of power from the sun. There's a couple of things that are common to buildings that are net metering customers or grid-tied customers, and they include a disconnect with a handle. This is required by net metering law in most states. What's also required is a bidirectional meter, and that bidirectional meter is installed by the utility company and is used to measure electricity into the building and electricity that goes out of the building, the excess electricity that's generated and put back onto the grid. This meter today is showing that more electricity is going out to the grid than is coming in from the utility. And it says that to date, 545 kilowatt hours have been sent back to the grid from this system.
People talk about, they get their electrical bill, for instance, they see this number they pay, so it times 5 cents or 10 cents. That number has to do with something called kilowatt hours. And we see these systems flipping through, and you're reading about photovoltaic systems. They always talk about how many watts a panel is. And people in their mind, they imagine that one could buy X number of watts of panels and then generate so many kilowatt hours. And it all seems very confusing. So what is it that when people talk about we've used so many kilowatt hours, how many kilowatt hours does one generate with a photovoltaic system? What is a kilowatt hour, for instance?
A kilowatt hour is 1,000 watt hours. And that is the number that you usually see on your electric bill.
So what is a watt hour?
So a watt hour, the way I like to explain it is if you have a 100-watt light bulb, and a lot of people have seen those in their days, a 100-watt incandescent light bulb. Mm-hmm. And if you burn that 100-watt light bulb for 10 hours, 100 times 10, you've used 1,000 watt hours. That's your 1 kilowatt hour, which is equivalent to 1 pound of coal.
So 1 pound of coal is 1 kilowatt hour of energy. And that would be the same as burning 1 100-watt light bulb for 10 hours or 10 100-watt light bulbs for 1 hour.
That's right. That's exactly right.
It's a lot of energy.
That is a lot of energy. And what you see in a traditional home in the U.S. is a lot of energy use. we don't have efficient homes. We haven't been raised in a country that has been in need of being frugal about its energy use, and so we're used to big energy guzzling appliances. One of my favorite things is to go into someone's kitchen and look around. Often there's 3 different places that the time's being kept and displayed. Mm-hmm. It could be a coffee maker, microwave, a range top, a clock on the wall. But these are just different ways that we lose watts every day, and we lose them without any real necessity. We could probably make do with 1 clock in the kitchen. This system here at Riverwalk building in Davis, as I said before, it has a 2.4 kilowatt array.
Okay.
Which means that at peak sunshine, and we're here at noon, sunny day, so peak sunshine, it's generating 2,400 watts of power. That's like having 2 microwaves turned on and feeding into the building instead of drawing power. And that's what the nameplate rating for a solar electric system means in terms of how much power it can produce. Now, as the sun moves away from noon and down closer to 4 and 5 in the evening, it'll stop making its nameplate maximum, 2,400 watts, and it'll make something less than that. You'll see the power drop off, and it'll drop down maybe, say, 1,500 watts to 800 watts until as you get into the evening and the sun goes behind the horizon, you're only making a couple watts, and then dark, boom, it's finished. But that's the beauty of solar. You know the sun's going to come up every day. It's going to go down every day. So every day it's making electricity. Even on a cloudy day, this makes electricity. It's just it doesn't make its peak output on a cloudy day. With this system being a commercial system, we had to do a special, it's called supply side tap, meaning the service conductors over here are tapped in this long trough, and that is what the PV is feeding back to. And this is different from how a typical residential installation is installed. A typical residential installation, the power that is produced by the solar can be fed back to a breaker on the homeowner's breaker panel. And it's a little easier, a little more straightforward to do it that way. But commercial installations are treated differently by the electrical code. So we have a supply side disconnect here, whereas with a residential system, which we'll see later, we just go to a breaker.
So again, I remember a few months ago, maybe it was a year ago, maybe it was longer, talking about you visited a community somewhere back to the east, maybe to the south, where folks had been running wind turbines and solar and stuff for quite some time, and off the grid.
Oh yeah.
12 volt, like automotive level wiring in the house, and such things. Solar panels, I think is.
Folks who are living off the grid.
Yeah.
Yeah, there's a.
It's like a community, an intentional community or something. So you went down and people had like fuse, like automotive fuse panels, running like 12 volt lights and that sort of thing.
There's a lot of the folks who started out with solar in the 70s and 80s ended up having to build their own control panels, which there's a pretty robust set of suppliers and manufacturers now for control panels for off-gridders or for even on-grid folks who want to use renewable energy. But yeah, in going to see some of these older systems, you do get a pretty good dose of just kind of people being resourceful. A lot of Radio Shack components and switches and fuses, including automotive fuses, just as a kind of a stopgap. It was do it yourself or don't do it back then. And
so these people are not connected to the grid in any way. They have electricity, and they're sourcing it from solar. How long ago was this?
All the way back to the Carter era, all the way back to
this is 30 years ago.
The late 70s, yeah.
So this is stuff that's been in operation for 30 years. I thought that as I read, that I see the, expected, service period, 20, 25 years. But he said this stuff was considerably earlier, than the stuff we have currently, and it's still in operation 30 years later. People are still making electricity with them.
That's right. The panels that these folks were putting in were not considered by today's standards to be very well constructed. The construction of a typical solar panel now is much better than what you were seeing in the late 70s, early 80s. But still, these panels, these legacy panels, continue to make power and continue to power people's homes. The expected life or service life on a modern panel is between 40 and 50 years.
So it's 40 to 50 now.
The warranty.
Does anybody really know?
No one really knows.
Okay.
No one's seen a modern panel through this 40 or 50 years.
Well, right, but even the early ones, those nice deep blue, selenium photo cells, from way back from the days of Telstar, from the 50s, literally. Does anybody really know, how long those things actually have lasted?
What was it? What bedeviled, I guess, the early panels was really a delamination problem and a condensation problem, where a panel's made with a glass front, and then you have your silicon wafer behind that, and then on the back you'll have some sort of protective backing, like a Tedlar, or you could even use glass, so some sort of plastic back there. But all these layers would start to kind of delaminate from each other and allow moisture to come in. That moisture would, of course, cloud the panel, and you'd see the panel's production drop. And that was the problem with the older panels. You don't see that with a modern panel. And the industry standard warranty on power production is 25 years. You get that with all the framed modules, regardless of whether it's made by GE or Solar World or Sanyo. Thin film is a different animal. You only get a 20-year warranty.
Right.
It's sort of a newer solar product. But yeah, solar is robust, and owing to the fact that it has no moving parts, it has a very long expected service life. And so we say 40 to 50 years because expectation is that warranty period is only going to cover half the span of the equipment service life.